Okay. On page 63 in your book, if you would look at the three examples under example 1. Now remember from last week, what you see up here is this. F of x equals something.
10.
Alright? Now from last week I told you that f of x is the function of x, and it's the same thing as what? It's the same thing as y. So even though these equations say f of x, g of x, that's the same thing as the letter y. Okay? Because it's a function of x. So a, they say, is a linear function. If you look, there is a y term. It's represented as f of x. There is an x term, and none of these rules are violated. If you look at b, however, that is not a linear function. A linear function means a straight line. Why?
Because
X is raised to the fourth power. Something with x raised to the fourth power is actually a graph like this. Okay? And eventually we're going to get into graphing these things. Recognizing what they look like, how they open, which direction, and all this other stuff. Odds and evens and all that craziness. But B is not a line. And then C is also not a line because why? X and Y are multiplied together. Okay? Now, how are linear functions used in everyday life? If you turn to page 64, there's an example there, okay? And the formula is given for you. And every linear equation, you got to understand, is a relationship between two factors, or two things. And the slope of the line, or whatever that happens, determines, as one thing changes, what happens to the other thing. Okay? We have slopes which do this. Which means as x changes, what happens to y? It stays the same. Alright? If you're looking at a line that has a positive slope, as x is increasing, what is y doing? Y is increasing. And then you also have lines that are a negative slope, which says as your independent variable increases, y gets smaller. Okay? And so all of these relationships are used in real life. And here's an example right here. Okay, in August, a Russian submarine sank to 350 feet in the Barents Sea. Okay, here's a linear function that can be used to represent the pressure at that depth at the bottom of the sea. Now, if a ship sinks, probably somebody's going to want to go down to the ship and try to investigate and see what happened, correct? Why is it important for people to know what the pressure is going to be down there? They need to make sure they have the right armor, or whatever you want to call it, equipment, so that their bodies don't just like implode, okay? Because you can't take too much pressure. So you need to know what you're up against. You can't just jump down there like this and go, hey, I'm going, 350 feet below the sea level. So according to this, now, here are the variables used. It's not x and y, it's p and d, but it's for a specific purpose. What do you think p and d represent according to that example? Pressure and depth. Okay? Now if you remember, we said that x is our independent variable, right? And y is our dependent variable. Pressure and depth. Which one of those is independent of the other? Doesn't matter what the other one is. Depth. Okay? Depth is your independent variable. Notice, normally we have f of x, right, equals blah, blah, x. Well, since depth is the dependent, there we go. Since depth is the independent variable, it's in the x's spot. If I was going to actually graph this, I would label the depth along the x-axis Because if the ship sinks, it doesn't matter what the pressure is, it's going to keep going until it hits the bottom, right? So basically what matters is how deep it is. But the pressure depends on how deep it is. And then what you're going to see here is that we're going to have a positive slope because the deeper you get, the higher the pressure is. Correct? Okay. So these things are used every day for people doing this sort of work or others, just all kinds of other stuff. All right? Meteorologists. Looking at temperatures and barometric pressures and all this other stuff and history and saying when the temperature was this way and the barometric pressure was like this and blah, 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 how many times did it rain? How many times did we have this? And they come up and they find and then they have their, 50% chance of rain. Okay? So these things are used. This is not just to make your life miserable. Matt, you had a question? Okay. Now, the question was, all right, we're going to go explore that ship. It's 350 feet below sea level. Find out the pressure. What do you do?
Plug in 350 for depth.
Very good. And you find out the pressure. And it's done in the book for us. It's 23,992 pounds per square foot. Okay? So you might want to be prepared, don't you think?
You should
Okay.
probably go in
Unless you're just committing suicide, then you can just jump in. All right. So anyway, here is an example of how this stuff is used in everyday life. Could anybody think of an example of how, or of a relationship that would have a negative slope? First off, let's think of two things that are related. Something independent, that as it increases or decreases, something else occurs.
batting average.
Okay, batting average.
Starts at 1,000.
Okay, so what's the independent variable?
I don't know. All I know is it starts at 1,000 and then drops.
Yeah.
Gas? Like human gas or car gas? Okay.
Like, as
Wow.
gas car increases, the amount of money you have in the credit card goes down.
Very good. That's very, yes, okay. I heard a very, sometimes in movies you have these quotes that you're just like, wow, that's deep.
It's Rocky Horror.
That's saying something. And we watched No Country for Old Men this weekend.
Awesome.
Are you serious?
Awesome show.
Oh my gosh.
It's so tight.
It's ridiculous, but anyway. But there was a point where they're sitting down, the sheriff and some of the old man, and they're talking about just how society is these days and how there's no respect and people are just killing each other and, just like nothing. And what's his name? Tommy Lee Jones says, once you stop hearing sir and ma'am, the rest is soon to follow. It's like, that is so profound. It really is. But
Serious stuff right
as the respect decreases, the rebellion increases. Okay? That would be a relationship. It's not a negative relationship, though. All right, well, let's not waste any more time on this. Okay. So far, we've looked at how to identify if something is a line. I want you to understand that a line is it's simply a representation of the relationship between two things. As one changes, what happens to the other? Okay?